So in the previous video, we built a user interface that can make an API call to our model, but this entire system is just running locally on our machine, and we want to deploy it onto the internet so that it can be used in an application and at a larger scale. And because there is a bit of custom configuration that needs to be done by loading these models off of our file system and using the FastAI library, I think it is better to provision your own instance to run these machine learning models as opposed to using any kind of turnkey solution, just because you want to have a little bit more leverage over your file system and your dev environment. So I'd recommend using something like AWS or GCP over something like Heroku or anything like that. So in order to deploy this instance, I'm going to make a new AWS instance. So I'm going to go to my AWS console, and I'm going to go to EC2 and instances and launch a new instance. Now, I'm just going to use an out-of-the-box Ubuntu instance that they actually have it in the quick start, Ubuntu 16.04. And I'm going to make a t3.large. There's no real reason for that. I just want it to be a little bit larger because it is using this FastAI library. We can't just use the free instance for it. So I'm just going to pick something that I know is kind of big. Configure instance details. I'm going to give it a bit of storage, 32 gigabytes. Yeah, and now I'm going to add a security group rule to open up HTTP traffic on port 80. So if you just go to HTTP, it opens up traffic on the default HTTP port, which is going to let us, when we make a request to the server API, we want that to actually serve the API that can, classify the watch images. So now I'm going to launch this. All looks good. I'm going to use that same machine learning server key pair and launch this instance. So once the instance is launched, it's going to give us an IP address for it. So we can go to our desktop and we can do SSH-I and then that machine learning key pair that I made earlier, .pem, and then we'll do Ubuntu at, and then the IP address of the instance, say yes, and we have a remote machine. So if we looked earlier on my local dev environment, I was using version Python 3.7.2. And by default, this Ubuntu 16 instance that's pre-made by Amazon comes with 3.5.2. So just to have it have, similar environment to my dev environment, I want to install Python 3.7. And this is kind of what you'll go through whenever you make a remote machine is you're going to provision it with some default libraries and default installations so that it works in a remote, roughly similar way to your local dev environment. So first things first is I'm going to do sudo apt update, sudo apt install software properties common. And this is just, and then sudo apt or sudo add apt repository, PPA dead snakes /PPA. And this is just letting our instance know about where the 3.7 Python installation is that we want to actually download. So I'll run sudo apt update one more time. And then finally, sudo apt install Python 3.7. So once that's done, you'll see that if we do which Python 3.7, we actually do have the Python 3.7 binary installed. But if we did which Python 3, we'll see that the Python 3 executables just map to our default binaries folder. But if we actually tried to reveal where that is mapping to, so ls-la user bin Python 3, we'll see that this is actually symlinked to the Python 3.5 executable. So we just want to change it so that when we call Python 3, it's using the Python 3.7 executable. So we'll do sudo ln-fs, which is how you force a symlink to something that's already been symlinked, and then user bin Python 3.7. user bin Python 3. And now if I did ls-la on Python 3, we'll see that it's mapping to the Python 3.7 binary. So next, I'm going to install pip3, which is going to be the package manager that we'll use to install Python libraries, and I'll copy this script. And again, all these scripts are going to be online on GitHub when I'm done with the series, so you don't need to pay too much attention to it. So now if I did which pip3, we'll see that we do have the Python package manager. Finally, the last thing that I want to install is that virtual environment library, so I can create a virtual environment like I had locally. So I'll do sudo apt-get install Python 3.7-venv. Yeah, so now that's all the kind of installations that I needed to do. And now I'm just going to now I want to SCP my local file server onto the remote machine so that we can have the remote machine running. So I'm going to make a directory here called chrono server. And then, I need to make a new tab. 1, 2. just making it a little bigger so you can see, I'll cd into my desktop/chronoanalyzer folder. And now I don't need to actually SCP the entire project up. I just need the server and the models. Yeah, so I'm just going to cd into Chrono Server here. And then here I'm going to SCP-I, then need the PEM file, desktop/keys/machine learning server. And then I want to SCP-R, because I'm going to SCP a directory, that entire models folder, and I'm going to send it to Ubuntu @ and then I need the IP address here. So Ubuntu @ this /home/Ubuntu/Chrono Analyzer. And that's going to set up, it's going to send our model up. We should be able to see this now, but we actually don't. And that's because I actually named this wrong. I named this Chrono Server instead of Chrono Analyzer. Yeah, so if I just cd into Chrono Analyzer now, yeah, we'll see that we do have that classifier.pickle. So let's just make a directory called models and then move that classifier there. Yeah, and then I'll make a new directory called server, cd into the server, and then let's SCP the server.py file into our chronoanalyzer/server, and then we'll SCP the requirements.txt file also. Yeah, so now if we look at our local machine, and we just did an ls in the server, we'll see that we have the server and our requirements. Okay, so I'll back up. And now I want to create a new virtual environment for the project. So I'll do python 3-mvenv myapp-env. And then we'll run source myapp-env/bin/activate. Now we're in that local environment. So now we want to run the pip3 installer to install the requirements.txt on the server. But one thing to note before we do that is we have to install what are called, what I like to call the alphabet library. So in like every new kind of Ubuntu machine that you ever run, you're always going to have something like this that's always installing these things like build essential and libssldev, and then like these XML, SLT, zlib, whatever, things like this. These are just like things to make the C compilers work properly. So I'm just going to run this script to install all these things before we try to install like that FastAI library in PyTorch. Yeah, so that's done. Now I'm going to do pip3 install-r server/requirements.txt to install like FastAI and PyTorch and those libraries. All right, so now that those are done, we should be able to run our Flask server with server.py. Yeah, and we see that we do run our Flask server on local port 8000. And yeah, so we have a remote server that's running the exact same environment that we had locally on our machine. And that local server has port 80, which is the default HTTP port, open to HTTP traffic. So one thing that we might try to do is just change the port that Flask is running on to port 80. But it's not actually going to work when we try this. Because Flask is going to yell at us and say that this is a development server. You don't want to actually use this as your like production web server, which you would if you were running it on port 80. So what we need to do instead is actually run a production web server, something like Nginx, and have that route traffic to the application server Flask that's running locally on our machine. Yeah, so let me quickly just change the port on our Flask app back to port 8000. And I'm just also going to make just a homepage route just to will help us test this. So yeah, app.route / goes to def home. And we're just going to return homepage from Flask. Yeah, and now let's install Nginx. So we can do that with sudo apt install Nginx. And we can start Nginx with sudo service nginx start. Yeah, and that's if we check the processes that are running, we'll see that we do have Nginx running on our machine. And if we went to this IP address now, like this is default on port 80, we can see that Nginx is working and we get the Nginx home screen. So now the only thing that we need to do is tell the configuration of Nginx to route HTTP traffic to port 8000 where that Flask app lives. So the configuration file for Nginx normally lives at /etc/nginx/nginx.conf. And this is going to be the configuration file that Nginx is using. So we're going to add something to the end of this where we're just going to add a server block. And we're going to say we want this server to first listen for HTTP traffic on port 80. And then we're going to tell it to route, let's say like the homepage location. So location slash, which is just going to be the homepage. And we're going to give it the designation proxy pass. All that this is telling Nginx to do is just when you get HTTP traffic on this route on port 80, just pass it to something that's running somewhere else. So we're using Nginx as a proxy for our Flask web app so that we can run Flask on our server, but not actually have to serve traffic on port 80. We'll have Nginx serving traffic on port 80 and just passing it on to Flask. And this is just what you have to do because Flask isn't meant to be run as a production web server. So yeah, we'll just say Nginx is our web server. We're going to pass that traffic to Flask. We're also going to say on location classify, which is the actual route that we had where we're making those API calls, we want to do the same thing. So we want to proxy pass HTTP 127.0.0.1 to port 8000. We're going to also say that we want to add headers to the HTTP requests made here. So access, control, allow, origin, star. And this is just to get rid of any of those CORS issues when we're trying to query this from localhost. So yeah, and we're going to say access, control, allow, headers to be equal to content type. So that we can, make the proper request. So anyway, once we do this, so there's actually one other thing that we need to do. If we cd into /etc/nginx, we'll see that there's a folder called sites available. And if we cd into that, we'll see that there's this file called default. And this actually has another Nginx configuration that by default it's going to use over the conf that we define. So I'm just going to remove this file. Yes. Well, it doesn't like me doing that, so I'm going to sudo rm this. Yeah, and once that's gone, now our conf file will actually take effect. So yeah, if I do sudo service nginx restart, just to restart the Nginx server, and go to our homepage, we'll see now it's not returning the Nginx homepage, it's returning an error because we're not running our actual Flask server, so chronoanalyzer server, and then Python 3 server.py to actually run our Flask server. Yeah, and now we'll see we get homepage from Flask. And this is the IP address of the server. So if we just opened up the UI that we had running locally, that was just hitting our server on localhost, which is running on port 3000, and just change this now to the actual deployed URI on the internet. And we tried it. Finder, let's get a picture of a watch here. We'll see that we do get our classifier, only now this is being served from a deployed web application. So now that our server is deployed and we have a persistent IP address for it, I want to deploy this UI to production so that the entire system is living in production on the internet and accessible to anyone. So I'm going to use Heroku to deploy this React app just to show kind of a different workflow that you might use to deploy something. There's a couple things we need to do to prepare this React app to actually get deployed to Heroku seamlessly. First thing we need to do is make a web server for it. So the React app is going to get built into static assets when we compile it for production. And then we just want to have a simple Node web server. I'm going to use the library Express.js, which is just like a very simple library for making web servers in Node in order to deploy this. So real quick, I'm going to go to my package JSON, or actually I can just do cd UI here and then do yarn add express. Yeah, and then I'm going to make a file here called server.js. And I'm just going to copy like pretty much the default starter kit for an Express app, which is just saying that on any route, I just want to serve the static HTML file and start it on the port that's in the environment variable here, which Heroku will set by default. And if not, we'll just use 3000. So we have this, and then we need to specify a proc file. So a proc file is what Heroku is going to read to know how to actually start our application once it gets the code for it. And we're just going to tell it that we want to run this web server. So let me just quickly make a proc file. And we're going to say that for the web process, so when Heroku encounters web process, we want to run node server.js, which is all that we would need to do to run the server. So the last thing we need to do is just compile this for production. So let me quickly just commit this code, git commit ready for production. Yeah, and then we could do yarn run build, which is the default create React app command to build your app for production. So once this is built, it's going to actually build it into that index.html file. And we're going to need to, I'm going to check out a new branch called production because we could see in our git ignore file here that the production build is being ignored by Git, which we don't want in our production because we want to actually push this to Heroku. So yeah, I'm going to add this now and just commit this with the message. This is a production build. And now we need to make a remote Heroku repository. So I think I can just do Heroku create and then the using the Heroku CLI and then the name of the on like repository on Heroku that I want to create. So I'll just say Jordan ML React or something. And yeah, so we get a Git URL for the Git repository. And now I can do git remote add Heroku and then just push this. Yeah, oh, I guess it actually already, by default, added that remote when I ran Heroku create. That's kind of cool. So now I can just git push Heroku production, which is the name of the branch I want to push to the master branch. So whenever you're pushing a branch to something like Heroku that's not named master, you can just tell it the branch that you want to push, but it has to be on the master branch of Heroku to actually run. So yeah, we're going to let this build for a sec, and then I'll come right back. Okay, so now that's done deploying. So if we get the URL that it deployed to, and I'll just do HTTP / and then that URL. Yeah, we see that our app is now, we get an app that's deployed on production that looks exactly the same. And if I go grab a watch and drag it on, we'll see that we get the prediction of the watch, but this is running in production, right, on a deployed URL as opposed to just locally on our machine. So yeah, we have a production system now that is using a classifier that we built.